Logistic growth. The model is the rate of change of population is given by this, where k is constant, p is population, and k, uppercase K, is the carrying capacity. Okay. Here, let's combine these two, 1 minus p over k. So we get k, p, k, k minus p. Okay, that is dp over dt equals. Okay, let's bring p, k minus p to the left side, means divide by this. So this k goes to the top. P, k minus p, and dp in the left side, and little k, dt in the right side. Here p is the population and t is time. Those are the variables. Okay, p is the variable, k is carrying capacity, that's a fixed number. Now we want to integrate both sides, and this one is simple, just kt plus some constant. Here we got a product on the bottom. P is the variable, so partial fraction decomposition. So k over p, k minus p is p and k minus p. Let's say a and b. Okay, that means k equals a k minus p plus bp. Let's take p equals k. That means k equals, this is 0, b times k. So we are trying to determine the values of a and b. So b equals 1. If we take p equals 0 here, then k equals, this is a k plus 0. That means a equals 1. Anyways, this fraction is in fact 1 over p plus 1 over k minus p. We got dp, we need to integrate. So we wrote this complex fraction as a sum of two simpler fractions. Now antiderivative of 1 over p is just natural log of p. And p is population positive, so we don't put absolute value, plus this is also positive. K minus p equals kt plus c1. Okay, here's a mistake. Derivative of k minus x, kind of, okay, dx. This derivative is negative 1, but there is no negative, so it got to be negative sign. Now we can combine these two logarithms. Difference of two logs is log of quotient, p over k minus p equals kt plus c1. Exponentiate both sides. So p over k minus p equals e raised to kt times e raised to c1, and I want to denote that by c. Okay, let's determine the value of c, and we need to isolate p, solve for p. So using initial population, p at 0, that's p naught. So this will be initial population p naught, k minus p naught equals e raised to t equals 0. So 1, so c is p naught over k minus p naught. Okay. Now we want to solve for p, this one. C is this fraction, so I'm going to just leave c for now. So from here, let's cross multiply. I have all over 1, so p times 1, p equals k minus p times this one. So c e k t times k minus c e k t times p. Here is p, so add this term both sides. Okay, add c e k t times p CEKTP. And so in the left side, then we can factor P out from here. P factors out 1 plus CEKT equals, this is left, so CKEKT. Okay, this is uppercase K. Now P is isolated, so P is CKEKT over 1 plus CEKT. We can simplify this. So let's divide top and bottom by C and EKT. Okay. Let me write over here. So P equals CKEKT dividing by C and EKT. On the bottom we got two terms, so we need to divide both. So 1 over CEKT plus CEKT over CEKT. So P equals, here just K on the top. This one is 1, right? So I'm going to write 1 first and then this one. So let me write plus 1 over C and move up, just a little bit up, so e raised to negative KT. Okay, and this is it. What is 1 over C, by the way? We can write A for 1 over C. So that is P at time t equals K over 1 plus 1 over C, let's say A, e raised KT. And where this A is reciprocal of C, and C was found here. C was P naught over K minus P naught. So reciprocal would be then K minus P naught over P naught. Okay, so this is the logistic growth formula, when the growth, population growth, not only depends on current population but also depends on the remaining room. Okay, final.